All right, let's get right into it. Today, we're going to make your company's data practically invisible to thieves. I'm going to walk you through, step by step, how to deploy silent, fully automated BitLocker encryption across all your Windows devices using Microsoft Intune. We're talking a complete, zero-touch solution from start to finish. Let's do this. So, picture this. One of your company laptops gets left behind in a coffee shop, or worse, stolen from a car. If that drive isn't encrypted, everything on it, financial records, customer data, all your secret sauce, is completely exposed. That is the exact nightmare scenario we are going to solve today. And you know what? The solution is already built right into Windows. It's called BitLocker. This is Microsoft's own full-disk encryption tool, and its whole job is to scramble your data and make it totally unreadable to anyone who shouldn't have it. Think of it as your absolute first and best line of defense against physical theft.
Okay, before we even think about building the policy, we have to get our environment ready. It's kind of like a chef getting all their ingredients prepped and in place. Honestly, skipping these prep steps is the #1 reason these deployments fail, so let's make sure we get this part right.
You see how all of this connects, right? You need the right license to manage things in Intune and the right version of Windows so you even have BitLocker. But the real linchpin, the piece that makes all the silent automation possible, is that hardware requirement, the TPM chip. It's like a tiny, secure vault built right onto the motherboard that holds the encryption keys.
So, how do you check for that all-important TPM chip? It's super simple. On any Windows machine, just type tpm.msc into the run box. Or, for all you PowerShell fans out there, just run get tpm. Either way, you're looking for one thing, a status that says ready. If you see that, you are good to go.
All right, with our environment prepped and ready, now we get to the main event, creating our security blueprint inside of Intune. This policy is what's going to tell BitLocker exactly how to behave on every single one of our devices.
And let's be crystal clear about our goal here. We want this to be completely silent, zero touch. The user shouldn't have to click a button, type a password, or even know that it's happening in the background. Encryption should just happen, automatically, invisibly.
Okay, so to get this policy going, you're going to head over to the Intune Admin Center. We're diving into the endpoint security section, which makes sense because Intune sees disk encryption as a core security function, not just some random device setting. From there, we'll create a policy, pick Windows 10 and later, and then select the BitLocker profile. Now we've got our blank canvas. And here we go. This is the absolute core of the whole operation. The next few settings we're about to look at are the secret sauce. They're what separates a clunky, manual process from a truly silent, zero-touch deployment. Let's look at exactly what makes it all possible.
Here it is, the key to making it all silent. Of course, we're going to enable encryption and allow the TPM to do its thing. But the single most important setting on this screen is Startup Authentication Required. We have to set this to No. This is what gets rid of any prompts for a PIN or a USB key at boot. The device just starts up, fully secure, and the user has no idea.
Next up, you get to pick your encryption strength. And look, while 128-bit is fine, the modern standard is XTS AES 256-bit. With today's CPUs, the performance impact is so small you'll never notice it, and you get the highest level of security available. For any professional environment, 256-bit is really the only choice.
Okay, this part is completely non-negotiable. What happens if something goes wrong and a user is locked out? You absolutely need that recovery key. These settings guarantee that the key is automatically and safely backed up to Azure Active Directory before encryption even kicks off. This is your safety net, and we're making it mandatory.
So, we've built our perfect security blueprint. Now it's time to actually flip the switch. We're going to apply this policy to our devices and, just as important, we are going to verify that it worked exactly the way we planned. Now, here's a pro tip for any major deployment. Don't just blast it out to everyone at once. Start small. Create a pilot group with a few devices you can easily check. Assign the policy to them, test it, make sure everything is working perfectly, and then you can confidently roll it out to the rest of your fleet.
This is the big question, right? Every IT admin asks this after they click deploy. Pushing out a policy is easy, but how do you know for sure that the drive is actually encrypted? You gotta trust, but verify.
The fastest way to get the ground truth on any device is with a simple command. Just open up Command Prompt as an admin and type manage BDE status. You're looking for 2 confirmations, conversion status, fully encrypted, and protection status on. If you see both of those, mission accomplished.
Okay, so the device is locked down. That's awesome. But we are not done yet. We have to check on our safety net. We have to make sure that the recovery key is sitting right where we told it to go. Because if you can't recover a device, the data is as good as gone forever. And to confirm that safety net is in place, just pop over to the Entra Admin Center. Find the device you just encrypted, click on it, and then go to Recovery Keys. Seeing that 48-digit key stored safely in the cloud, that's your final confirmation that the entire system is working perfectly from end to end.
Look, in a perfect world, every deployment would work flawlessly on the first try. But we live in the real world, so let's really quickly cover a couple of the most common hiccups you might run into and how to fix them fast. One of the most common errors you'll see is when a device was already encrypted, maybe by a user or some old policy. Intune tries to apply its new policy and gets confused. The fix is pretty simple. You just run a command to turn off the old encryption, give the machine a reboot, and then let your shiny new Intune policy take over correctly.
If BitLocker just plain refuses to start, always go back to the basics. Is the TPM ready? Is Secure Boot on? If you see the key isn't getting stored, double-check the device's Azure AD join status. And sometimes a device just needs a little nudge. Forcing a group policy update and a simple reboot can work wonders.
And just one final quick reminder, because it really is this important. If you take away only one thing from the configuration part, make it this. Always use 256-bit encryption. It is the modern standard for a very good reason.
So let's zoom out for a second. What have we really done here? By following this blueprint, you've gone from hoping your devices are secure to knowing they are. You have rolled out a powerful, automated security control that protects every device in your fleet, without you or your users having to lift a finger.
And that's really the beauty of this whole thing. This isn't just about checking off a compliance box, it's about fundamentally improving your entire security posture in a way that is completely invisible and seamless to the people actually using the devices. Thanks for joining me for this explainer.